Welcome to Programming in Modern C++. We are in week 1 and we are going to discuss module 5. In the last module, we have seen some of the common algorithms being available as a part of the C++ standard library, and we have also seen how to use sorting and searching particularly to great benefit. Now, as you all would know that in programming, what comes closely with the algorithm are data structures, right. That is what we say, that algorithm and data structure together forms the foundation for problem solving. So, as some common algorithms are available, in this module we will take a look at what are the common data structures that are also available as a part of the C++ standard library. We will use stack as our vehicle to understand that and see the difference between a stack written by the user in C and a stack provided by the C++ standard library, and then see what are the other data structures that are also available in C++ standard library. So, this is our outline, which you will see on the left all the time. So, first let us look at a stack in C. So, before I get into that, just for completeness, let me quickly go over the concept of stack. Stack, as we know, is a container which maintains the data element in a last in, first out order, called the LIFO. That is, the element that is added last to the collection will be removed first, and we conceptualize that as if it is a vertical structure stack of books. The one you put on the top is the first one you have to remove, that is it. So, for creating a stack, we need to decide on these things. We need to decide on the data type of every element, whether it is a stack of integers, stack of double, stack of strings, or stack of user defined structures, and so on. We have to define a structure, a container structure, to maintain the stack. Theoretically, a stack is infinite, but in reality it cannot be. So, you will have a maximum size also associated with the stack. So, you would be familiar with stack being implemented with arrays, stack being implemented as list, or stack being implemented as some other DQ structure, and so on. Now, we also need to declare a top variable, which is the marker of the topmost element. So, that if I want to add an element, it goes on top of that. If I want to remove the element, the last in element, which will be first out, I need to move the top in the other direction. That is the purpose of top. And the whole functionality of stack, the data structure, is defined in terms of 4 operations, as we know. Push, that is adding an element; pop, that is removing an element; top, that is what is the current topmost element, if you want to check that, several algorithms will need that; and a fourth is to say whether the data structure at all or the stack at all has any element or not, that is empty. Okay. With these 4 functions, we have a total conceptual model for a stack, the last in first out. Right. Now, in C, if you are writing a stack, then you know that if you change the data type of the element, then you have to re-implement the stack, change the code. That is, the stack code for an integer and stack code for double elements would be different. Okay. And the change is needed in the structure, which subsequently changes all the function code. So, the entire implementation has to be redone, retested, and all that. And unlike sine, atan, square root, these kind of functions in C standard library has not provided with a ready-made stack, for the simple reason that if the data type changes, then the whole implementation has to be different. So, you have seen in QSort or in bsearch how complicated it was to work with the algorithm without actually knowing the type of the data. Right? Here you will have to do it for all these functions and so on, very complicated. So, the designers decided not to provide any ready-made stack in the C standard library. Now, we all know, this is just a quick recap of what you know. We all know that stack is a very important data structure, because it is very common to solve a whole number of problems. For example, you can use a stack to reverse a string. All that you need to do, put the elements one after the other in the stack, and then you just take them out one after the other, push, 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 pop, 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 will reverse the string. Very simple, last in first out to reverse this. We can evaluate postfix expressions. For example, here I have an expression this, where the postfix is 1, 2, 3 star plus 4 minus. I think you know postfix notation. If you do not, please read it up. Actually, stack can be used to convert an infix notation like this to the postfix notation also. This conversion itself can be done using a stack, but here what we are focusing at is the evaluation of it. So, if the expression is given in postfix, then how do you evaluate? Take a stack. If you keep on scanning the input from left to right, if you have a value, put it in the stack. So, you put 1, you have a second value, put it in the stack, push, third value, push, then you get an operator. The moment you get an operator, you know what is the arity of the operator, that is how many operands will it need. So, you take out those many elements from the stack one after the other. So, as you have got star, which is multiplication, which is binary, you take out 3, you take out 2 and do that operation. As you do that operation, you will get 6, put it back. Okay. So, 2, 3 is gone, 6 now comes here. Then you have a plus. So, again you do the same thing, you take out plus as binary, take out 2 elements, 6, 1, do the 6 plus 1, 7, that goes in. Then you get 4, so you push it in, then you get minus, which is a binary minus here. So, you take out 4, take out 7, do 7 minus 4, get 3, put it in. You are at the end of the input. So, your process is over. What remains in the top of the stack, it should contain actually only one value. If everything is correct, that is your evaluation result. You can check it out. If you look into this expression, this is the highest precedence, for 2 times 3 is 6. Then these have equal precedence, but left associativity, so 6 plus 1 is 7 and 7 minus 4 is 3. So, we have got the correct result. So, stack has a wide application in terms of this kind of expression evaluation, and as I said, it can be used to convert an infix to a postfix also. It can be used to identify palindromes. Palindromes are which read the same from both sides, like Malayalam is a palindrome. You read it from left to right, you read it from right to left, it reads the same. So, this can be used, this detection can be used by stack. You can, as I said, convert infix to postfix, you can do depth first search, so many different things, post order traversal, all of these things require stack, highly useful. Okay. So, let us try to recapitulate writing a stack in C. So, this is the structure I define, where I have used an array as a container and I have used an array index variable top as a marker. So, each one of these functions are global the stack functions are global, because in C all functions are global. So, I need to pass the stack as a parameter to each one of these. So, each one of them takes a pointer to the stack. Push in additionally will need the element that is to be pushed, is a stack of characters. So, it takes a character, everything else does not need another element. So, here you check for whether your top is equal to the initial value, here you provide the current top value, here you increment the top, get the next empty location in the array and put that element there. Here you decrement the top to logically remove the element. For simplicity, where what here we have used the protocol that pop just pops, it does not return the value that it gets, that it has. So, to get that value you should first do top and then do pop to remove it. Right? So, that is a simple way of doing it. Okay. So, now what I will have to do? I will have to declare a stack and also initialize it with the value of the marker which shows it is empty. Now, since I have used an array, so the index starts from 0. So, I say that the index which is invalid, empty index is -1, 1 less than that, right. So, this is the initialization that I need to do. Then I have an array. Now, I am trying to array of characters, I am trying to reverse that string. So, I keep on taking character one by one, keep on pushing them in the stack that I have. I am using that particular stack, and once I am done, then I keep on finding the top and popping it, top, pop it, top, pop it. So, I am taking out in the reverse order till the stack gets empty. Right. So, using these 4 functions, I can easily do this kind of programming, which I am sure most of you have done already. Now, let us see. So, another example, postfix evaluation. I will not go through the details, but I can just highlight the stack creation definition part of it is the same. Again, I have to provide that, and then for doing this evaluation, I have to check if something is a digit, because then I have to push it, or if it is an operator, then I have to take out the top 2 and operate. So, if it is a digit, I push, otherwise it will have to be an operator, because that is the only 2 things that are available in a postfix expression. So, I take out the top 2 elements one after the other, and I already know what the operator is, which is in CH. So, I do a case of possible operators, and whichever it matches, I will take the 2 operands op1 and op2 that I have got, operate them according to the operator, and the result I put back to the stack. I keep on doing this till I come to the end of the postfix expression and things going correct. At that time, I will have only one element left, which is the result in the stack, which I take out as top. Postfix expression evaluation very smoothly done. Right. So, stack this kind of programming is very common. Right. So, if we now step ahead and look at what happens in C++. In C++, the standard library provides a separate header, a separate component called stack. And the interesting part is that is a stack of any type as you want. Again, uses that magic of templates, meta programming, right. We will come to that later on. So, let us look at, on the left is your C code. So, all these I have skipped it here, all that you wrote for the stack function, stack structure is to be given, which is given in say header stack.h that you have written, and then you have to define an initialize and then do this algorithm to reverse. In contrast, in C++, all that you need to do is to include this header. It gives you the entire stack, correct one. And when you want to create, all that you do is, you remember this style was used in vector also, we did vector end, right. This is that template style where you say that the stack is written assuming that the data type could be anything, it is a variable. And now you are saying that assume that the data type is char. So, compiler will take that and create the set of codes that are required for a stack of char and compile them. So, you have your ready-made stack right through writing just this couple of characters. And once that has been done, rest of the code works exactly in the same way. So, you have a lot of advantage now, because lot of code that you had to write in terms of stack.h is not required. There is no code that needs to be written here. You needed a separate initialization, which if you forget or do erroneously, everything will fall apart. There is no initialization required in this case. The whole cluttered interface of stack functions, which require every time the stack pointed to the stack to be passed, are not required. You are just calling it as functions of that particular stack object. It is a clean interface, and here you have to write it for every type, you have to write separately, test it. It is quite not only laborious, but it is error prone. Here there is just only one code which is well tested, and rest of it the automatic generator is doing. So, it is available in the library, very less amount of work, right. So, that is the advantage of having data structures as a part of your library, which C++ strongly provides. Okay. So, this is just for your completeness. This is the postfix evaluation code written in C++, which is exactly same as the code that you wrote in C, except for the definition of the stack and this particular component from where the stack codes are coming. Everything else is the same, and it is just a matter of couple of minutes in which you can easily write such code. Now, having said that, you understand that stack is a data structure, and in generality C++, or I should more specifically say C++ standard library, calls the data structures as containers. Because what is a data structure? Data structure is basically a way to keep the data, keep a collection of data, and then a certain protocol of operations that you can do on it. These two together forms a data structure. Stack also maintains data, array also maintains data, queue also maintains data. Every data structure you think of, it has to store certain amount of data, and they differ in terms of the operations that you. So, stack does a LIFO, queue does a FIFO, array does a random access, and so on and so forth, right. So, C++ prefer to call them as containers. So, there are in C++ standard library, there are several components for different containers. They are ready-made, and the most important point to be noted, which is what we will keep on learning all through this course, so that even we can write similar libraries in future if we need to, is the fact that every container works like a data type. Every container works like a data type, and that is the beauty of the whole thing, and we will slowly understand that. There can be, the containers can have elements of varied type, including user defined types, and are defined in that appropriate way. So, in C++, these containers are called holder objects that can contain the collection of other objects or its elements. As I said, it is implemented using class template. You will learn that later on but just consider that it is a kind of a magic where you write the template of the code, the basic structure of the code without having to write, without using the knowledge of the element type that is involved. You take the element type as if as a variable, and then when it is used, the element type is known, the compiler generates a code for that element type and compiles it. So, that is the basic. So, it manages of course, it has to manage the storage space because it is a container, and it provides functions to access them, which makes it a data structure, right. A collection to store data plus the operations like push, pop, top and empty makes something a stack. Similarly, so the functions to access them will be provided. It also supports iterators. I briefly mentioned in an earlier module, iterators are nothing but generalized for loops. So, you can provide on your data structure, if you can provide a range, then you can go from one end to the other end of the range doing something. You can go in the forward direction, you can go in the reverse direction. Now, having structured in this way, some of the byproducts or design advantages that you get is several containers have member functions in common. For example, in general, let us think of if you have a data structure, what are the common things you will always have? First of all, there will be a way to create it and there will be a way to destroy it. Of course, that has to be there, that is true for everybody. In most cases, there will be a way to add an element, there will be a way to remove an element, and in many there could be a way to find an element, and so on and so forth. So, there are a lot of member functionalities which are common or are shared, and C++ standard library makes use of that. So, once you understand the basic philosophy, common philosophy of these data structures, you learn all the data structures together, you do not have to remember everything, right. That is the beauty, and we will see that more. Now, some of the containers are known as container adapters, because they are not new containers. There is some container and they just being adapted to behave differently, giving us a different set of functions. For example, let us say if I implement a stack using an array, then the basic container is the array, but I do not want to see that as an array, I want to see it as a stack. If I see it as an array, I will do random access, but I do not want to do that. I want to look at it as a stack that which gives me push, pop, is empty and top, right. So, I am adapting the original container array with a set of functions which make it behave like a stack, right. So, it is not a fundamentally different, whereas if I talk about a linked list, it is a fundamentally different container than an array, because it does not have random access, but it has the ability to random insert, random delete. If I am talking about a tree, it is a fundamentally different container, but when I am talking about array and stack or say list and stack, stack is not a different container. It is an adaptation of a existing convenient container. The similar thing is for the queue or for the priority queue, which some of you may know as a heap. It is also called the heap data structure. The heap sort is based on that and so on. So, containers are not, therefore, are not full container classes. They use some underlying container and provide a specific interface relying on the object of one of the container classes. Right. So, stack is one kind of interface, maybe on an array, queue is another kind of interface, maybe on an array, or stack is one kind of interface on the list, queue is another kind of interface on the list, but the underlying container is a full container and these are just adapters. And these adapters are very important for writing several good algorithms. So, do not get shocked by looking at this list. Obviously, on day 1 nobody expects you to remember this, but you have to with use get accustomed to this set of data structures, because they are available in the C++ standard library. So, you do not have to do anything, just instantiate and you are ready to go. And these data structures are designed in a way so that most of the common problems that you have to solve using data structures are available here as ready-made. So, if we quickly take a look, forget about those which are marked as C++ 11. We will talk about them when we come to the modern part of it. We have already seen what is a vector. It is an array with a lot more of power. We have a list which is bidirectional list, doubly linked list what we call. So, it can be expanded and contracted at both ends and works in that way. We have a DQ which is double ended queue, which means that you can add and remove element at both ends. What is stack? Stack is where you add remove elements at one end. Queue is where you add element at one end, remove element from the other end. And DQ is a generalization where you can add and remove element from both ends. Right? So, you have all of that ready. Then you have adapters like stack queue, priority queue with the expected member functions that are there. Exact member function name you have to know, but the beauty is the function name to add is same between stack and the queue and the priority queue. So, once you learn one, you know the rest. Then you have a set of containers which are associative. What does associative mean? In array, stack, queue, priority queue and so on, you find out an element based on either its position or its priority or its order of arrival and so on, not by the value of the element. Right? You never need to know the value of the element to do these operations. To do push, pop, top, empty, you are not concerned with the value of the element that you are dealing with. All that you are dealing with is the order of the arrival and the order of departure of the elements to the data structure. There are several containers where you need to do the other way. You are concerned about what is the value. For example, you are creating a set. Now, set does not have any ordering, as you know. It's a structure. Mathematically, it is a collection where the elements are unique and have no specific order. Right? So, here these kind of containers are called associative. There is a map. Map is nothing but name value pair. You have a key and a value. The keys are assumed to be unique, so that given the value of the key, you can find out what is the value of the associated with that particular key, which is very, very required. Right? This can be, for example, map can be used to represent a graph, where you have associations between two nodes by an edge, which gives you the graph. Right? So, set and map. Map is also commonly you will be commonly known as a hash operation, but here it's little different. Hash directly is not available. So, these are associative, where the value is the important part in keeping in the way you keep it in the data structure. So, set and map are the fundamental ones, which in an underlying way use a binary search tree structure. The underlying structure is a binary search tree. Right. Now, binary search tree per se is not given in as a component, but this set and map, they use binary search tree internally and obviously need the elements to be comparable. Now, so which is little bit maybe for a set it may be little bit uncomfortable, because you want to make a set of anything. And if you have to build a binary search tree based on the elements of a set, you have to make them comparable, and which may not be little unnatural. So, there are some unnaturality in that. It also have multiset and multimap. Multiset is a set where duplication is allowed, multimap is one where duplication in terms of the key value is allowed. And this need to be comparable is done away with in C++, where you have unordered versions of them, but as I said, we will not talk about these right now. So, we have overall given a view of the availability of data structures in C++ as a standard library, using stack as a primary vehicular example, and this will be very useful for you to develop C++ programs very easily. Thank you so much for your attention, and we will meet in the next module.